Thank you very much, Bert. I would like to say to anybody in the audience that you are very welcome, even if you do not understand dynamic line rating, loop flows, intraday transmission capacity markets, the distinction between DSO and TSO, or what a regional control center is. But let me just try to make that slightly more clear. The dynamic line rating is using the data of the day to see exactly how much you can send through a transmission line. The standard rating is usually based on a hot summer day when there are limitations that do not occur every day, and you can thereby use the lines for higher transmission than the rated guaranteed capacity from the supplier. Loop flows means that you send electricity from northern to southern Germany via Poland, for example, and they might, in some conditions, think that that is unfair because you don't pay for it, but you use their capacity. The importance of intraday capacity markets or is to control that you actually know what is the cheapest available electricity generation in the system, taking into account that transmission capacity is not absolutely constant because there may be failures and things. You must correct me if I'm wrong now. I'm trying to make it very simple here. And the distinction between distribution system operators and transmission system operators is in Europe that while the transmission system operator who is in charge of the high voltage transmission system ensures that there is balance between production and consumption and is always very strictly unbundled from generators, the distribution grids, where there is generally significant overcapacity and little problems with generators owning these grids, they are just distributing electricity to households and small industries and are often locally owned, and there are many different ownerships for those. The regional control centers is just European politics, so I don't even bother. The German situation regarding the subsidies, I think you did make the very important point that we have now reached a situation where new renewables in Germany do not require subsidies, at least not in the cases you mentioned for offshore wind. But the old subsidy system said that the consumers have to continue to subsidize the plants that were built even 10, 15 years ago, and therefore the consumers still have a lot to pay in Germany. But it will soon end, they hope and think, for good reasons. But thank you very much. I hope some people feel a little bit more welcome when I try to explain some of these terms. On the panel, we have 3 more speakers, and I would like to give the floor to Wakeyama-san from the Renewable Energy Institute, who will describe a little bit of the Japanese situation.
Thank you, Thomas.自然エネルギー財団
I am Wakeyama from the Renewable Energy Institute. I would like to, well, Carlos-san and Mr. Yamazaki, these other panelists will talk in more detail, but from my side, I would like to talk about what kind of grid issues are being discussed in Japan at the moment and future prospect, and how does the discussion in Japan link with its discussions overseas. These are the topics I would like to cover. First of all, these are the grid-related issues we are facing in Japan. There are 3 of them. First is the issue of grid connection. Throughout Japan, this is a nationwide issue, most notably in Tohoku. And concerning this issue in the Tohoku region, there's an increase in renewable energy application, and there is a queue of companies waiting for a renewable energy grid connection. Companies, when they want a new grid connection, they have to bear the cost of a grid enforcement and so forth, and that's making it difficult for them to gain a grid connection. And the second challenge is flexibility. Particularly, the Hokkaido EPCO area is facing this issue. Hokkaido does not have so much electricity demand, but there's an increase in renewable energy connection, and the electricity adjustment speed is not catching up with the demand. And in order to respond to this variability speed, new applicants have to pay for storage batteries. That's the rule. And here, once again, the new applicants have to pay the cost, which makes it difficult for them to newly apply. And the third issue is demand and supply. I would like to raise the example of Kyushu EPCO. 2017, last year, in May of last year, a solar output was 76% of the electricity demand at 1 p.m. And Kyushu EPCO traded electricity outside of the region, and that's how they are striking balance. But by introduction of renewable energy, there may be curtailment of curtailment, and we have rule of curtailment without compensation, and the risk for new applicants is that curtailment may come without compensation. So in order to overcome these issues, I've raised 3 points that are necessary. First is improvement of grid availability. Secondly, more flexible electricity system. And number 3, more economic cross-regional operation. And in order to promote them, these 3 measures, we need to disclose information and monitor the information that is disclosed. So I would like to explain in more detail about these 3 viewpoints. First, the issue of grid connection. The issue of grid connection, in order to solve this, an important point was raised in Mr. Maise's presentation, that is to reduce congestion. According to conventional grid connection rules, new applicants were served on a first-come, first-served basis. And here, existing companies had the right to use the grid on a maximum capacity basis. And when new applicants applied, if there is no capacity available, in order to avoid congestion, the grid had to be reinforced. That was the rule. In other words, as Mr. Mais mentioned in his presentation, congestion management was not introduced at that time. And first come, first served, and maximum capacity, these were the standards by which grid became available, which created a very conservative grid allocation system in Japan. And as a result of the conservative grid allocation in Japan, as I mentioned at the outset, at Tohoku Electric Power, applicants ended up facing congestion. So the congestion is not as serious as the actual electricity flow. As a result, grid reinforcement becomes necessary, and new applicants, some of them end up giving up. And in the future, this first-come, first-served system may create over-congestion in the grid in the future. So this is the grid connection issue. And Connect and Manage, Japanese version of Connect and Manage system is considered to be introduced. New applicants for grid connection. If there is a grid congestion, their output will be constrained. With that condition, they'll be allowed to connect to the grid. Specifically, N-1 disconnection and no firm connection and more reasonable valuation of power flow projection. These assumptions be considered. New applicants, when there is congestion, if they allow to curtail, then they can connect. So in order to make this grid connection more efficient in the future, what is necessary? As Mr. Miles mentioned in his presentation, redispatch becomes necessary. And redispatch is another congestion management method. In a nutshell, it means that including existing power source, when there is grid congestion, not only new applicants, but existing businesses as well will have their output curtailed. That is what we mean by redispatch. And as at 50 hertz, their situation is written. There's a great power flow from north to south, and as a result, there's a great congestion. Redispatch in Germany is the kind of system where that the thermal system will be curtailed, and that is how the congestion is controlled. And if that does not mitigate congestion, wind power and other renewable power will be curtailed to reduce congestion. So this kind of congestion management, by introducing them efficiently, we'll be able to connect renewable energy in an efficient manner. The second point is the issue of flexibility. I introduced you the Hokkaido case. There's an increase in renewable energy connection. As a result, against the renewable energy variation speed, the adjustment speed is not catching up. That is the issue here. So when we say flexibility, we mean the output speed of the power plants, minimum output, and operation costs and so forth. According to Japanese conventional rules, we had the output of long-term fixed power sources. And according to this conventional rule, nuclear power and hydropower and geothermal power, for these kinds of power sources, at certain output, they are able to output on a preferred basis. But in the Hokkaido area now, nuclear power plants, when they start operating again, the fixed power source ratio will end up being too high. Specifically, in Hokkaido Electric Power, if all of the nuclear power plants resume operation, and if hydro power generation increases, when there's low demand in months like May, the long-term power fixed sources will end up exceeding the demand. So this means that there is lack of ramp-up down capability to variability of load and renewables. And in order to respond to this risk of ramp-up down capability to variability, in Japan we are asking for a cost burden of storage battery system for new entrants. However, cost burden of storage battery system by new entrants, for solar and wind power, cost will be increased as a result of that, and it will make it difficult for new applicants to come in. So a new concept that is necessary in the future is for both new and existing operators, we need to increase the flexibility of the power plants. In other words, flexibility of existing thermal power plants would have to be used to its maximum extent, and we would also require flexibility for new power plants, Hokkaido Electric Power. According to their analysis, currently in the Hokkaido area, combined cycle gas turbine is being constructed, and variability of output in a minute, 3 to 5% is the result of the analysis. However, this 3 to 5% from a European perspective, it's relatively low. For example, German consulting company Agora Energy Wende, according to their statistics, 10 to 15%. For existing power plants, 8 to 10% variability is possible according to their report. So for both existing and new power plants, we need more flexibility. That is what we need in the future. Finally, the issue of demand and supply operation. I talked about supply and demand balance for Kyushu electric power. One solution to solve this issue is to improve efficiency of cross-regional demand and supply operation. That was also explained in Mr. Masa's presentation. In order to realize this, what's necessary is more flexible operation of grid connection rules. First come, first served was the interregional grid rule in Japan, and interregional grid capacity is allocated for up to a maximum of 10 years. That was the rule. On the other hand, the remaining capacity was to be used to conduct power exchange. And that made it difficult to promote power exchange. And as a result, renewable energy had to be supplied locally, not beyond regions. And that made the issue more serious. And in Japan, to respond to the situation, we are trying to use the wholesale market to come up with a better inter-regional grid rule. Implicit auction is being considered. Implicit auction will be linked to the wholesale transaction, and as a result, the capacity of interregional grid can be used more flexibly throughout Japan. And in order to further improve the situation, one important point is a grid is now open to the market, and as a result, the electricity market will have to increase its flexibility. Mr. Mais referred to this point. For example, in Japan at the moment, wholesale gate close is 1 hour. And Mr. Mais mentioned that gate close is 15 minutes before. TSO, it's not the TSO's adjustment capability, but market adjustment capability is used to its maximum extent. So how to increase the balancing capability of the market, that I think is an important discussion that's needed in the future. So I talked about 3 important points: improvement of grid availability, more flexible electricity system, and more economic cross-regional operation. Currently, already in Japan, based on these 3 points, we are improving our daily grid operation, and in order to make further developments, we would like to cooperate as much as possible. Thank you very much.
Thank you very much, Wakeyama-san. I think you managed to explain most of the special features also so that the Europeans could understand it, and I think those of us who are not used to the Japanese system find in particular that the idea of using the first come first served principle for the transmission capacity, resulting in the privilege of the oldest, often least modern, most inefficient and therefore most expensive power plants to use the capacity instead of the newest, most efficient, lowest cost plant seems to be just the opposite of what we are trying to achieve in the European setting, where we want to minimize the cost of electricity supply. Also, the long-term fixed power concept is strange to the Europeans, because in Europe, any power company has, in exactly the same way, to offer electricity to be delivered the next day and promise to do so, and if you fail, you have to pay for the compensation that the transmission system operator has to do to ensure balance in the system. And while it might be difficult for wind and solar operators to predict their production the next day. They have become quite good at it, as Bert mentioned. Operators of large coal and nuclear plants often have it easier to predict, but they can never predict for certain. And when they fail, so that suddenly a large capacity is lost the coming day, it becomes very expensive for them to compensate for their unpredicted loss of supply. And that is not dealt with in the same neutral way in Japan, which is also something that they benefit from this special classification. So thank you. Now we are going to have another international outlook, and now it's Carlos Gascó from Iberdrola in Spain, who is going to tell us something of their activities and I think show a little film on how this daily operation of a transmission system is done. The floor is yours.
Thank you. Thank you, Thomas. Just a second, please. I need to make a little adjustment here. It will take a fraction of a second. All right.
A fraction of a second?
Yes, that's very a fraction of a moment. Okay. Well, before I say anything, I would like to express a personal feeling. In Spain today and in another country, another 40 countries, is Women's Day. We have a call in Spain to strike. It's a feminist strike to fight injustice, discrimination, and unfairness towards women. I cannot strike because I'm working in Tokyo, but I would like to add my thoughts, and I would like to add my voice to the cause as a son of a woman, husband of a woman, and father of a woman. And therefore, I would very much like to join what's going on in my home country. Now, having said that, I will say something related to the issue that brought me here today. Finally, I will only speak for a couple of minutes and then I will show you a video about how we deal with these issues in my own company. Grid and system integration of wind and sun. The most important thing to us as investors in wind is to understand the technology. The critical issue is to understand wind and solar production. And it's not always so simple. We need to think that wind and solar production is reliable. I often say here that it's unstable. It's not unstable. Things like voltage or frequency issues are clearly taken care of. It's not an issue anymore. It was maybe 15, 20 years ago. It's also predictable. It's been said before. Bart said it. You said it, Thomas. Our control center, we have 3 control centers for renewable production, one in Spain, one in the UK, one in the United States, predicts 90% accurate the production the day ahead. 97% accurate the production 3 hours ahead, which means that we know what's going to happen, which means that we can actually accommodate that production into the system smoothly. We can prepare the system and we can speak to the TSO and we can communicate with the TSO and the DSO and we can make it happen in an efficient, cost-efficient way. The key word has been said before. Everybody's talking about flexibility. It's not new. It seems to be the key new brand thing because everybody talks about the variability or the instability or the volatility of renewables. The load curve is volatile. The power systems have been able to cope with ramps for hundreds of years already. It's not new to the system. Now we have to enhance flexibility because we're going to increase the share of variable renewables. But we already have the tools. We know how it's done. We just have to develop, make an effort to make sure that it happens, again, in a cost-efficient, smooth way. Backup system flexibility comes from CCGTs or OCGTs, comes from hydro, comes from interconnections, comes from storage. We have storage doesn't only come in the form of batteries, it comes also in the form of pump storage, which we heavily invest in. We need to develop the tools to have flexibility rewarded in the marketplace. We're working on that. There is still room for improvement, but it's the way forward. And we have to do, as developers, our homework, investing in control centers that actually can do the best forecast available and do real-time management of the generation assets for wind and solar, which means that we can follow the instructions of the TSO, and we can communicate to the TSO, we can go downwards, we can stop, and we can rearm our wind farms on real time as is required by the system. And now, I will finally shut up and show you the video that I wanted to play. Yes, because it will show the features of one of our control centers, the one that we actually run in the United States. I don't know what happened, but it went wrong. Okay.
Well, let me just say this. At Iberdrola Renewables, our mission is to lead the transformation to a clean energy future. And we've got a really interesting and unique relationship.
Yeah, sure. Okay, finally. Thank you very much. It's only 2 minutes, so hopefully the delay is not too bad. Here it is.
Well, let me just say this. At Iberdrola Renewables, our mission is to lead the transformation to a clean energy future. And we've got a really interesting and unique relationship between our trading floor and what goes on in the control center.
My name is Kip Blair, and I manage the National Control Center that's here in Portland, Oregon. An average day here in the control center is largely going to be driven by weather and production.
So the NCC is the nerve center of our operations, and what we do is manage our dispatchable resources in order to generate energy in a reliable and efficient fashion.
A lot of people have the perception that you stick a wind turbine out in the middle of a field and you just let it run. And the reality is that the grid is very complex and demand is always changing.
There's a lot of complexity that we have to deal with on a daily basis, and we have the most technologically advanced systems to allow us to perform that.
You know, some specific examples of things that we're doing here in the control center, we're monitoring for lightning. We have a lot of biologic monitoring that we do.
We want to be able to run our fleet in a safe and reliable manner, but we also very much want to maintain the environmental aspect of our job, which is making sure that we protect wildlife.
What we are able to do with the marriage of the trading desk and the NCC is really put reliability back into renewable energy.
We do most of the forecasting, predicting, the NCC feedback, the real-time information. Typical day on the floor, we have a team of experts that gather supply and demand data, weather data, and financial data, and we use that data to try to monetize the value of Iberdrola Renewables asset portfolio, and it's all about volatility in the energy markets.
The amount of people that we have working those desks, the amount of experience that they have, allows us to deliver renewable energy across multiple markets. Through our innovation, through our technology, through our people, we have led the transformation in the renewable energy industry.
Thank you very much.
Thank you. And now the final member of this panel, the Director of New and Renewable Energy at METI, Yamazaki-san. The floor is yours.
Thomas, ありがとうございます。
Thank you, Thomas. My name is Yamazaki, Director of New and Renewable Energy Division. I just would like to thank you for inviting me to this prestigious meeting. Last year at the Revision Symposium, I think that was held the day before yesterday, the expert meeting was held, and I had the honor to participate in the meeting. It's indeed international information, the new pieces of the issues of Japan, to reveal them. This meeting has been very meaningful. I just would like to thank you for that. You have been focusing on grid, so I would like to also focus on grid. But since this is a valuable opportunity, I would like to share with you the overall picture of policies where we are headed. About renewables. Policies on renewables, particularly in relation to grids. So this is about how to integrate. That is really an essential part, given that the other countries, Europe, in the United States, I think it was the same, but we are faced with market reform. So it has to be addressed in a package with the market reform. Feed-in tariff, as you know, the 2012, from July, we introduced that FIT. But at the same time, after the great earthquake, we had round of discussions, and with 3 steps. Government is now reforming the Japanese electricity market. As was already mentioned, if you look at the Japanese electricity market for as long as 65 years, 9 or 10 utilities, vertically integrated EPCOs, had enjoyed a monopoly in a given area. The very thin interconnection lines were there, but they were actually had a monopoly. Each given the EPCO had that monopoly for quite a long time. In other countries, especially in advanced countries, we didn't have that. We didn't see that, but partly because of the lack of METI, Japan had that kind of regional monopoly, and that had a significant effect. This is a fact. We can't hide that. But it is changing these days. 2015, the OCTO was established, the Organization for Cross-Regional Coordination of Transmission Operators. Yes, it's true that we received a lot of criticism, but in a wider area, TSOs, TSOs should be addressed. Now we have this neutral organization, OCTO. So that's how we started. As for the retail market, 2016 April, the full liberalization of the retail market. You could buy the energy from anybody, and you could also choose renewable energy source. So that market has already been established. Having said that, more importantly, 2020 April, there's going to be the legal unbundling. That legal unbundling has already been decided. So we have 2 more years to go for distribution transmission to be fully unbundled. From 2013 or so, I have been participating in this project to address the electricity system reform. But if you look at the EPCO's behaviors, now they have changed so much. In 2020, transmission and distribution will have to be unbundled with more neutrality. Now, this is irreversible. And then I think EPCOs are now taking that move as irreversible move. Of course, they are still lacking many things, but this has been a movement of electricity market reform and introduction of renewables. It's important that these two go hand in hand. That's the understanding of the government. Renewables, as you know, since the introduction of the FIT, particularly on PV, it has enjoyed so much growth. 2016, annualized figure, it's about 30% the increase in terms of the speed. More recently, the pace of growth has shrunk a little, but 2016 in the middle, 2016, including hydro of all the power sources, kilowatt hour, 15%, actually 15.3% comes from renewables. 15.3%. We will intend to increase it 22 to 24%. That's the lowest level of goal set by the government. I said lowest because this is the minimum goal. As from the Renewable Energy Institute, you have been scolding me as it's too low. Yes, I agree with you. It's too low. I agree. But if you look at the current situation here in Japan, I will touch upon this later, compared with Western nations, this is twice as much in terms of the cost of renewables. Given that with the same cost, it reaches 24%, it's going to be a bit problematic. The cost needs to come down further. We also need to overcome the grid-related problems. When we see all these problems cleared, then 20-odd% renewables, we are always saying it is not the cap. It is not the cap. Today in the Diet, there was a stop in the upper house, the hearing, and if the question was raised, the Prime Minister said that this is not the cap. So going even beyond 24%, if all the other conditions are met, it can go higher than 24%. At any rate, it's 15%, and we intend to increase it to more than 24%. Time is short, so this can be a very challenging matter. I won't dwell on this, but about there has been so much bias on the PV and renewables. The introduction in Japan has been going on with so much emphasis on PV. There are 2 key words that we've been having discussion with. Renewables, make it the main source of energy. So far, renewables, introduce it as much as possible. So that was a kind of a sensitive expression. But August last year, in our basic energy policy discussion, making renewables our main source of energy. To make it happen, what should we do? Based on that understanding, we are advancing policies. Second issue, the large amount of introduction, large volume introduction. I don't know how it's described in English. Renewable energy, era of introducing renewable in a huge volume, and the next generation system network. So for the huge introduction, what are the issues on the network? How to address this network? We started in December 18th last year to make it mainstream, the huge volume introduction. This is a strong determination, and with that resoluteness, the government is addressing these. And there are 3 major issues. First, high cost. Unfortunately, currently, as was mentioned already, for instance, offshore, in the German, they already had a case without subsidy for PV, and 5 cents, it's around 5 yen. And that's for the purchasing price, that's nothing new, but if you look at the Japanese tariff, it's still expensive. So how to lower this? That's of course important. For the time being, starting this year, we incorporated the auction system, the 2 megawatts or higher in PV. So widening this and introducing this to other areas is a possibility. We would like to be meticulous and utilizing the competition. How can we lower the cost further? That's one thing we would like to try. So far, there has been so much focus on PV. PV installation, particularly in Japan, it's relatively easier compared with other types of renewables. Partly because of that, there has been so much focus on PV. Wind power generation, that's today's theme. The EIA can be so demanding if it's offshore wind power generation. There are no rules to utilize these offshore areas surrounding Japan. Also, no coordination scheme to talk to the fishermen. Partly because of that, many businesses have difficulties, as you can see on the bottom. For offshore wind power generation, in order to promote this, a bill is now being studied at the government. Tomorrow, actually, if everything goes smoothly, tomorrow it's likely to be passed as a cabinet decision and submitted to the Diet. So that's going to be the final stage for this bill to be passed. So right after this panel, I have to go back to do this work, to pass this bill. I won't dwell on the detail, but in Europe, there's a central methodology. We would like to use that as a reference with zoning system, with the price of auction. There will be the selection of businesses who will be doing the business, the large volume introduction, cost reduction, how best we would have it both. The offshore wind power generation is going to be one model. And then grid. I've been asked to wrap it up. So now grid. We've been talking about this, and Dr. Wakeyama nicely summarized the issues here in Japan. So in a nutshell, to introduce the renewables, the biggest issue here is grid. As I said at the outset, there are 9 EPCOs, all separated, and they kept separate. And that situation has not really been alleviated, and that's really the fundamental cause. There are local issues, many local issues actually. In any case, enforcement of grid, there were certain places where grid needs to be enforced, but that cost of enforcement, even with that, the electricity cost, the generation costs going down, but then the transmission costs going up. But overall cost, it's going to come down. That's the kind of framework we want to realize. But before enforcing this, there are certain things that we must do. As Dr. Wakeyama mentioned, connect and manage. We are trying to introduce this connect and manage system. Very briefly, what are we trying to do? Dr. Wakeyama, actually, he didn't say because he was paying attention to what I had to do, the 3 things we intend to do. This is about calculating, number 1, calculating free space. So, as Wakeyama-san mentioned, as you can see in the left-hand side, at the moment it's full max, and then you do the summate, the tally, and if it's full, and then it has to be reinforced. But there are power flows. The actual power flow base it should be, and also when there's PV operating, when there's a wind generation, they're moving. There are time differences can be. So the number 1, the gap that needs to be addressed. So it has to be actual flow. April soon. For all EPCOs, it should be applied. Merit order for thermal best performance for RE. In the North Tohoku, there is a process. And then they have already introduced that, the pilot, 2.8 million kilowatts, that was available. But by rationalizing this, the power flow, of course, it depends on the power source, 3.5 million to 4.5 million kilowatts. Suppose that it's 4 million kilowatts. It used to be 288 million, but now it's 4 million. That's 1 times 1.3 or 1.4 grid capacity. Just one example. So starting from April, at all EPCOs it will be introduced. Number 2, N-1. So for emergency, the lines are sort of set aside for emergency. But under certain conditions, they will be made available. Under that condition, securing almost half of installed capacity, but release that space by installing transfer trip related for accident. With the one that will be suspended, the one where the cost will be paid, is it going to be the same or not? Dr. Wakeyama talked about the redispatch, existing power source. Will it fall into the redispatch scope? Yes, I agree. But those the existing ones, how are they going to pay? How are they going to receive? How are they going to be compensated for? This is really a major issue. It cannot be resolved so easily. But of course, we will take up this challenge and we will do that. Then we really have to address it. But there will be those payers, there will be those people who will suspend this. If that's the same person, same organization, it can do that. So we would like to do that starting from April. In a certain 20% or 30%, the capacity expansion can be done based on that certain computation. Non-firm connection, that's the last one. There's this congestion management, looking at the curtailment. So curtailment, yes, but it is all right to connect accepting a certain curtailment under certain situations. So if there is this suspension, what kind of impact it will have on your place or that place, we have to do the simulation. So we would like to learn from the advanced cases from other countries. But it's going to take 1 or 2 years, not something we can start from April before we can come up with framework. So without the grid reinforcement, this is really about utilization of the existing capacities, the connect and manage Japanese version. So there are those people who are in the queue, and we would like to facilitate the grid connection. So this is going to be the very first step about the Japanese transformation. The expenses, they are so expensive, or that the period is so long. There are many related issues. We would like to address them. That's all. Thank you.
And I would like to welcome all the speakers to join me on stage. One of the points that you just made, I think, is very important to explain, that transmission investments are made to reduce the total cost for the consumers. And when you come as far as to see the distinction between power generation cost and power transmission cost, Bert, please come, you too, you often see that the distribution cost is very high compared to the generation cost. But it's important to know that the transmission part of that cost is very low. I think in Europe, typically 5 to 10% or even less. I don't know if you have a more precise figure, but something like that. So indeed, you may reduce the total cost for the consumers by investing in the transmission capacity. I would like to bring up a couple of issues on the Japanese situation. We have heard that there is now an ambition to leave the system with first served, first come for the transmission capacity. But at the same time, we heard something about a 10-year right of way for the oldest generators. Does that mean that we will have to wait to the mid-2020s before the capacity is fully available for everyone, or is there some intermediate measure? Please, can you comment on that? There is a microphone, yeah. Just talk.
ありがとうございます。
Thank you. With regard to your question, yes, first come, first served, that rule, to make it flexible. Yes, I just talked about connect and manage. Yes, that's one of the essential parts. Yes. Regarding first come, first served, yes, the very first applicant gets the right. That's the system. So this is really about the property right issue. So it's not that we are denying that property right per se, because that can be problematic if you do that. Let's see. we shouldn't just rob the organization of that right of property in overseas countries. I don't think that's the case of robbing organization of that right, property right. But as I said, that with the full specification, you do all the tallying, adding up, and then do this first come, first served. We don't do that. And yes, the assumption is that it will be suspended for a certain time, but if the person who pays, it would be different from the ones that suffer from the stoppage. We need to tolerate that. That's how we would like to create system. I hope that you will forgive me, because that's to the extent I can discuss, including that 10-year issue, grid capacity is allocated up to 10 years. At the moment, there are those who have vested interests, and then there are those new entrants with renewable energy. How to strike a balance between the two? First, we will have some space. Yes, we may have to suspend all those old players, but if it's just to say you will not be compensated for that, it would make it difficult. So what kind of a rational system we can create? Yes, we would like to continue to address that.
Like that in Europe would be dealt with by a one-off payment for them to give up their privileges in order to, from that on, avoid unnecessary inefficiencies in the system at large, and that would be justified. But we had another issue, and that was about the battery requirement, which I believe is not a law, but something that is decided by the Japanese power companies. Is that correct, Wakeyama-san? You mentioned the requirement on batteries for wind power plants. That's not a national legislation, but it's a grid code decided by the electric power companies. Is that correct?
Based on the law, for example, it's not the Agency of Natural Resources and Energy that's saying that, but the Hokkaido Electric Power is making that request. That is how the system works.
The first time that the requirement was a maximum ramp rate of 1% increase or decrease in power per minute, and that batteries were required, or wind power plants, I thought that must create an enormous market for battery makers for the nuclear power plants, because if they suddenly break down, their ramp rate will be much more than 1% per minute, and in order to be allowed to operate in the Hokkaido electric system, they must buy an enormous amount of batteries. This kind of requirement from a European or North American perspective, Carlos, can you comment on the how is that dealt with in the systems that you run the control of your wind and solar on? How is the ramp rate issue discussed?
Well, I'm not really an expert on the ramping system. What I can tell you is that we don't have a requirement to produce a given ramp. We have a competitive approach to actually delivering what the system is requiring.
No.
So we don't have a requirement anywhere I'm aware of to install batteries of any kind. The studies that I have seen indicate that the batteries are more efficient and cost efficient in the distribution systems,
right,
or even behind the counter at home, depending on the kind of contract that you have. In the transmission system, there will be, at this stage, still a controversial decision to be made. When it comes to backing up, storage at transmission level, our experience shows that the way to do this today will be, it won't possible with pump storage, which is available and has been around for quite a good number of years.
Bert, can you comment on how this is dealt with in the European TSO system?
I don't know all the details, of course, but I can say that we are using flexible 5 megawatt batteries in our TSO system in order to create flexibility and also for the grid congestion. And on the ramp rate, but probably that differs from technology to technology, but I can say that the interconnectors, DC interconnectors, that they have a ramp-up rate of 100 megawatt per minute. So in 10 minutes, we can stop the direction, and for 1,000 megawatt, we need 20 minutes to reverse it completely. So.
My comment on the relationship between the problem of managing a nuclear reactor scramming and the variation in wind power, do you think that was a fair description, that the nuclear power plant suddenly stopping is a worse problem from a ramp rate point of view than the variation in wind power in a system like Hokkaido's with many wind power plants?
Yes, it is. In our system, we still have 4,000 to 5,000 megawatt of nuclear power plants with a peak capacity of 13,000 megawatts. So it's very, very important. And unfortunately, we do have a lot of fallouts of these nuclear power plants in the last years. So it's certainly a big issue. But thanks to all the technology that I described a little bit, we were able to deal with these unexpected outages of nuclear power plants. But the risk of that is increasing. That's correct.
Wakeyama-san, you had in your slide the idea of utilizing other power plants' ability to adapt. Can you say something on the what kind of power plants is it that would handle the ramp rate issue in Hokkaido? That
output change rate to respond to that thermal power plant, I think would be the first possible capability to be used. And in the case of Hokkaido Electric Power, gas-fired power plants with a high ramp rate, they don't have so many of those gas-fired power plants in Hokkaido. So in order to connect more solar and wind power, more storage batteries become necessary. That's the logic in Hokkaido.
Nuclear reactors, how were they then handling a sudden scram of a reactor? Is that by the transmission line to Honshu then?
Hokkaido Electric Power's power source plan and the transmission, when they come up with their plan, there's N-1. When the nuclear power plant fails, whether there's they try to have no impact on the overall system, so they take the N-1 disconnection method. So even if there's a sudden failure in the nuclear power plant, in terms of frequency or power system, it's not the case that there's going to be a detrimental impact on them immediately.
Just a few minutes left. I think I would give each of you the opportunity to suggest what would be the most important change of policy or principle in Japan to increase the opportunities for wind and solar to increase in the system. Carlos.
That is a question worth billions. I don't know if I have it, but I would suggest the unbundling and the creation of an institutional structure that will allow this to happen in terms of TSO, DSO, and market operator will definitely allow the right decisions to be taken from a technical and from an economic point of view.
Yeah, Wakeyama-san.
I have a slightly different viewpoints, and I was not able to explain in detail. Information, disclosure, and monitoring, I think, is very important. After the Great East Japan earthquake, ever since UPCOS is available, there's a lot of evolution, and by taking a look at various data that's disclosed, we are able to analyze what kind of improvement is necessary. So this, I think, is quite important, information disclosure monitoring.
Thank you. Yamazaki-san, what's your priority? What do you spend your days trying to achieve?
すみません、私は提案を受ける。
I am the one who receives the proposals. So yes, I would like to humbly receive your proposals and suggestions, but just from a different perspective. Last year, the Iberdrola And the others, I actually visited Spain to have a discussion. And this is what I felt strongly. TSOs, in our case, it's TDSOs, but with them, the renewable generators are actually juxtaposed as kind of the in adversarial positions, like enemies in investment. There's that too strong a color of that adversarial system. The Iberdrola, 98% prediction is possible, and for the dispatch, you can actually respond to this. Here, there's a wind. There's no wind. So Spain as a whole, as a supply, you can count all of them. So for renewable generators and TSOs, DSOs, they are in harmony. They are coordinating. So if that takes place in Japan, a larger amount of renewable can be introduced as policies. That's the direction we would like to follow.
Thank you. And finally, Bert.
Well, I was also about to say what Carlos said, shareholder unbundling, but I think you have to be realistic that even that will not come before 2020, because then you will have legal unbundling. But to say something realistic, I think you should increase the power of that OCTO organization for cross-regional coordination of transmission operators. I think that you should more people from all energy sources into that division, that they can come up with innovative ideas how to increase cooperation and coordination between the transmission operators in Japan, and that can already help a lot, I think.
Thank you. Thank you, all four of you, very much for making it easy to keep the time schedules. And now we have a 15-minute coffee break before we resume at 20 past. An applaud for my colleagues here.